Hello, my name is Christopher Tate. I'm a Red Hat Research Principal Software Engineer, and I work with the New England Research Cloud and several universities like Boston University, Harvard University, and Northeastern University to deploy applications in the cloud. We have our own Red Hat OpenShift environment at the New England Research Cloud, and I want to show you what's going on there. So this is the URL, console.apps.shift.nerc.mghpcc.org. I'm going to go there and load the dashboard. So this is going to have me log in, and when I'm working on projects with the universities, I log in with MSS Keycloak, which lets us access different logins for different universities. And so I log in with my Red Hat account and take a look at my workloads. Now, today, I want to introduce you to a new project called AI Telemetry, and you can find it. It's open source. Go to github.com/ocp-on-nerc/AI Telemetry. And this is our open source project. We have some documentation here. The background of it is that we have GPUs that we're utilizing, and we want to build new dashboards with access control to see what's going on with these GPUs and how they're being utilized and improve the user experience for understanding GPUs and their utilization. So we're going to deploy several microservices. And in our project, I've taken all the microservices to 0 replicas so that we can do real deployment of Zookeper, Cluster Manager, Apache Solr Search Engine, PostgreSQL relational database, and Keycloak for fine-grained access control, as well as a message broker, RabbitMQ, and also a NoSQL database, MongoDB. So let me show you here our project. So this is the pods that we have running in our AI telemetry project. And my favorite tool for doing software development in the cloud is OpenShift AI. So this is Red Hat OpenShift AI. I'm going to click here and jump into OpenShift AI. So this allows us to set up projects where we can work together, like me and my buddy Dheeraj, as well as Cristiano and also Thor. We're all a team working on this AI telemetry project, and we're running workbenches. So I'm going to open my OpenShift AI workbench here, and you see I have a VS Code environment directly in my browser, and it's connected to my project. And I can even, in the terminal, check on the pods. So OC get pod, and there we see the pods. And I can do -W to watch the pods, because we're about to deploy a bunch of things. So I'm going to put these side by side. I'm going to put pods over here and jump back into my notebook, and we can do these deployments. So first, I'm going to deploy our Zookeper cluster manager, and this is used by multiple applications like Apache Solr and our AI telemetry project, so that we can share messages across pods. So we can have multiple replicas of Solr, we can have multiple replicas of AI telemetry, and they can share work between them because they have a cluster manager that shares messages and says, hey, who's available to take this task? And one pod will say, I can, and the other pod will say, I can the next time. So you can share the load. So I deployed Zookeper with a Helm chart. So I do Helm, upgrade, install, which is basically an upsert or update or insert command. Zookeper, and this is the Helm chart, and with some parameters that we set. And if we check down below, let's see if it's running. It says it's running. So now we can move on to Solr. I'm going to run these really fast, so I click Run All, and it's going to rerun Zookeper and then it's going to check that Zookeeper's running, and then it's going to move on and start deploying Apache Solr. Apache Solr is our open source search engine, and it allows us to have a really cool searchable API for the data in our AI Telemetry site. And we're going to wait for the Solr pod to become ready. It's running, but it's not quite ready yet, as you can see here. So we also installed this with Helm. It's a different Solr Helm chart from Bitnami. In fact, all of these are Bitnami Helm charts. They're very, very useful and easy to deploy. Now this one takes about 1 minute and 6 seconds to deploy, I think. So we got to be patient here, but it's worth the wait to have a search engine, I promise. Okay, Apache Solr is ready, so we move on to deploying PostgreSQL. So here it goes. We have our container creating, and we'll check if the container becomes ready with these commands. PostgreSQL is ready and running. Now we deploy MongoDB, our NoSQL database, which is used to deploy FireWire IoT edge device components. And check if it's ready. MongoDB is ready. And then RabbitMQ for our message broker. This error is okay. You need a secret to create RabbitMQ, and it already exists, so we don't worry about that. We see that it's deployed, and now the pod is running and becoming ready. And it's ready. Now we deploy our last microservice, which is Keycloak for access control. It installed with the Helm chart, and we'll just wait for the pod to become ready. This one also takes a little extra long, about 1 minute or 2. But having access control to your application is really nice. In fact, for development, we have a GitHub identity provider installed so that we can authenticate with our GitHub account, since that's what we use anyway for open source software development. Let's also check on the logs of Keycloak. Okay, everything is good.